Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others in need of assistance with these topics. So we're going to be covering today's videos. We're going to be looking at trigonometry, and we are going to be using the law of sines and or the law of cosines to determine a missing angle or a missing side for triangles. And this will be the fourth part in this series. So we have this first triangle right here, and we are tasked with determining what is this angle X on the inside here. So we have a 14, a 10, and a 6 for this triangle. So we know all the sides of this triangle, and we don't know any of the internal angles. So anytime that you know all three sides and you do not know an internal angle inside your triangle, you want to use the law of cosines in order to solve for your missing angle. So the law of cosines can be written like this, where you have c squared is equal to a squared plus b squared minus 2 times a times b cosine of the little c angle. So you have this side C, side A, side B, and this angle C. Well, side C will be the side that is opposite the angle you are looking to find. So this 14 would be my side C. Side A and B are just the remaining two sides. Doesn't matter which one is A, which one is B, but they are the ones that are not opposite the angle you're finding. They are the ones touching the angle you are finding. And then little angle C is the angle that you're looking for that is opposite whatever you are calling side C. So let's go ahead and plug in our numbers here. So we would have 14 squared for side C is equal to 6 squared plus 10 squared minus off 6 times 10 times the cosine of my angle X. So we are looking for angle X here. So let's do some rearranging here. I'm going to take this entire portion right here, flip it to the left side, and then bring the 14 over. So I'm going to end up with 2 times 6 times 10 cosine of X is equal to 6 squared plus 10 squared minus off 14 squared. And then I'm going to divide everything by 2 times 6 times 10, divide everything by that. So then I'm just left with cosine of X on this side. So on the right side, I would have 6 squared plus 10 squared minus off 14 squared. All of that divided by 2 times 6 times 10. And then this whole side on the right side here of 6 squared plus 10 squared minus 14 squared divided by 2 times 6 times 10. That gives me exactly, hang on, cosine of X would be equal to exactly minus 0.5. So in order to find what the angle X is, which I'm just going to go up here now, I would just take X is equal to the cosine inverse of minus 0.5. And once you punch that into your calculator, your angle X would be 120 degrees, which makes sense because it is an obtuse angle. It looks like it is larger than 90 degrees. So we have our angle X, which is 120 degrees. So that's how you would utilize the law of cosines to find that internal angle that's unknown for a triangle that has all three sides known. Alrighty, so moving on to our second triangle here. Let's see what's going on. Well, first off, the X that we have to find is now a side of the triangle. We have the other two sides of 5 times the square root of 2, and this one is 7 times the square root of 2, and we have an internal angle right here at 45 degrees. So for this one, we could also use the law of cosines to find this missing side of X, which the law of cosines, as you may remember from the first part, is this, where we could set our side C as 5 square roots of 2, A would be 7 square roots of 2, and B would be X. And then the little angle C, remember, is just what's opposite your side that you're calling C, which would be 45 degrees. You could work the law of cosines that way if you wanted to. That's perfectly fine. But since we utilized the law of cosines in the beginning with the first problem, let's just work this problem with the law of sines just to show that you can do it the law of sines. It's just going to be a little bit longer than doing the law of cosines for this particular triangle. Now, that's not saying that the law of sines will always be longer than the law of cosines to work with. Just in this particular triangle, it will be. So using the law of sines and not the law of cosines here, the law of sines states this, that you will have the sine of an angle A over the side of A is equal to the sine of angle B over the side of B. And just like with the law of cosines, where C and C were opposite sides and angles, same thing here, where this little sine of A will be the angle opposite the side that you're calling A. So in order to use the law of sines in order to find x, we have to determine what this angle is here, which is opposite my x. Well, how are we going to get there? Well, we're going to have to use the law of sines pretty much twice in order to find out what's going on here. So we will use the law of sines for the first round to determine what this angle is opposite the 7 square roots of 2. And let's just call that little angle B. So in order to do that, once we find this one, the angle B, since I know that the internal angles for a triangle all have to add up to be 180 degrees, I can find the angle opposite my x and then use the law of sines. So let's go this route. So my first round here, I'm going to use the sine of my angle A, which I'm just going to call 45 degrees over here. Call that sine of angle A. And then over side A, which is opposite whatever you're calling sine of little a, so that would be equal to my 5 square roots of 2, or divided by 5 square roots of 2. And then that's going to be equal to my sine of angle B, which I'm calling this one up here, divided by the side that is opposite that one, which is the 7 square roots of 2. So we can just rearrange here. We're going to have to cross multiply to find out what's going on here. So once we cross multiply, we end up with 5 times the square roots of 2 times the sine of B is equal to 7 times the square roots of 2 times the sine of 45. Thus, the sine of B, it will be equal to 7 times the square root of 2 times sine of 45 divided by 5 square roots of 2. And then we can just take the sine inverse of all this. So my side, or my angle B, sorry, will be the sine inverse of all of that right here. So once you do that, this pops out to be approximately 81.87 degrees. Well, that means that this angle up here is the 81.87 degrees. So to find this angle that is opposite x, I will just take 180 degrees, minus off the 2 internal angles that are known at minus 45, and minus off the 81.87. And that gives me an approximate angle of 53.13 degrees. So now I can use the law of sines with my side x as my unknown. So let's just repeat this first portion right here. We're going to use the sine of 45 over 5 square roots of 2 is equal to the sine of the angle I just found of 53.13 degrees over the side that is opposite that, which is my x, my unknown. Once again, cross multiply and then divide by whatever's attached to the x. So once you do that cross multiplication and division, you end up with x is equal to 5 square roots of 2 times the sine of 53.13 divided by the sine of 45. And this will pop out a side of x equal to exactly 8. And that's how you would use the law of sines in that case. As I said earlier, this triangle would be a little bit faster if you use the law of cosines, but just showing you how you can use the law of sines to also find this one, just a little bit longer of a procedure, but it can be done. So I hope this video was helpful, and if you want to see more problem solve this right, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out greatly on this side. Thank you for watching, and I hope you have a fantastic day.